With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Two separate cylinders of masses m is equal to 1 kilogram and 4m and radii r is equal to 10 centimeter and 2 are rotating in clockwise direction with omega 1 and omega 2 respectively. Now they are held in contact with each other as in figure. Determine their angular velocities after the slipping between the cylinders stops. So as soon as you bring these two cylinders in contact with each other, what will happen is, on, let's say this is cylinder 1, this is cylinder 2. So on the cylinder 2, to oppose its motion, there will be a frictional force F acting in this direction. Similarly, an equal frictional force will act in this direction on cylinder 1 to oppose its motion. Now, these frictional forces will apply some torque, and that torque will result in the angular acceleration or retardation of these cylinders. So for cylinder 1, FR1 should be equal to I1 alpha 1, which means FR1 is given as R is equal to, now I1, since these are cylinders, so it will be 1 by 2 M1 R1 squared times alpha 1, which means FR is equal to 1 by 2, M1 is given as M, R1 is R squared alpha 1, which means alpha 1 is equal to 2F upon MR. Equation number 1. Similarly, for the second cylinder, FR2 will be equal to I2 alpha 2. So FR2 is 2R is equal to, once again it's a cylinder, so M2 R2 squared alpha 2, which gives me F2R is equal to 1 by 2. M2 is 4M. Yes, M2 is 4M times R2 is 2R squared alpha 2, which gives me F is equal to 1 by 2 4M times 2R alpha 2, which means alpha 2 is equal to 2F by 8MR. This is the second equation. Now, since before bringing in contact with each other, they both were turning in clockwise direction. Once they are in contact with each other, one of them will have to turn in the opposite direction. And to reach that opposite direction, it has to change its direction, which means at some point it will achieve an angular velocity of 0. So let's try to find out the time after which any one of them achieves an angular velocity of 0. So 0 minus omega 1 is equal to the angular acceleration minus alpha 1 times t1, which means t1 is equal to omega 1 by alpha 1. Now omega 1 is given as 100 radian per second, so I'll write it as omega. So omega upon 2f, alpha 1 is 2f by mr, so 2f by mr, which means mr omega upon 2f is t1. Equation number 3. Similarly, for cylinder number 2, 0, which is the final angular velocity, minus omega 2 is equal to minus alpha 2 t2, which means t2 is equal to omega 2 alpha 2, which means omega 2 is 200 radian per second. So in terms of omega, it will be 2 omega. since I am assuming 100 radian per second to be omega, so 2 omega by alpha 2 is 2f by 8 mr, which means f by 4 mr. So f by 4 mr is equal to 8 mr omega by f. This is equation number 4. Now clearly T1 is less than T2, and since T1 is less than T2, what that means is that it's the cylinder 1 that changes its direction. So because the cylinder 1 is the cylinder that is achieving a zero angular velocity earlier, so that means it is changing its direction earlier, which means that it is the only one which is going to change its direction. So cylinder 1 is the one who will change its direction. Now let's say these are the final angular velocities: omega 1 f, omega 2 f. Now the final, when they have achieved their final angular velocities, they are no longer slipping. So if they are no longer slipping, so at the point of contact, their velocities are going to be same. So that means at the point of contact, v1 should be equal to v1 should be equal to v2, and if v1 is equal to v2, so omega 1 f r1 should be equal to omega 2 f r2, which means omega 1 f r is equal to omega 2 f 2r, which means omega 1 f is equal to 2 times omega 2 f. This is equation number 5. Now let's analyze the motion of cylinder 1 after it had achieved the zero angular velocity, which means after it had changed its direction. So after it had changed its direction, the final angular velocity is omega 1f minus, after changing its direction, so initial velocity will be considered 0, because when it was 0 was the moment it was changing its direction, is equal to the angular acceleration alpha 1 times, let's say, a time t in which it achieves its final angular velocity. So omega 1 f is equal to alpha 1 we had calculated earlier, so from equation number 1, 2f by mr times t, equation number 6. Now for cylinder 2 never changes its direction, so its initial angular velocity will be omega 2 and final will be omega 2f. So omega 2f minus omega 2 is equal to its angular acceleration, which is alpha 2, times now the time period that the second cylinder takes to reach from its initial angular velocity to the final angular velocity will be the sum of this time t that was taken for the cylinder 1 to reach from 0 to its final velocity, plus the time in which the cylinder 1 stopped for the first time. That means the time that the cylinder 1 took to reach from its initial velocity and omega 1 to 0. So what I mean is that this time let's say capital T. This time capital T is the time cylinder 2 takes to reach from omega 2 to omega 2 F, and it comprises of two times. The time T taken by cylinder 1 to reach from 0 to omega 1 F plus time taken by 1 to reach from omega 1 to 0. So I can write omega 2 final minus omega 2 is equal to, now this angular acceleration, there will be a negative sign here because this angular acceleration for the second cylinder is slowing it down, times t plus the time t1 which was mr omega by 2f. So mr omega by 2f. Now let's put the values. So this gives me omega 2f minus omega 2 is 2 omega is equal to minus alpha 2. Alpha 2, value of alpha 2 we calculated earlier. So alpha 2 is f by 4 mr. So f by 4 mr times t plus mr omega by 2f, which gives me omega 2f is equal to 2 omega minus ft by 4 mr minus omega by 8, which means omega 2f is equal to 15 omega by 8 minus ft by 4 mr. This will be equation number 7. Now I have equation number 6 for omega 1 final, and I have equation number 7 for omega 2 final. So let's take a ratio of these two. So omega 1 final upon omega 2 final is equal to 2ft by mr. So 2ft by mr upon 15 omega by 8 minus ft by 4 mr, and from equation number 5, omega 1 final divided by omega 2 final is equal to 2. So 2 is equal to 2ft by mr upon 15 omega 8 minus ft by 4 mr, which gives me 15 omega by 4 minus ft by 2 mr is equal to 2ft by mr, which means 15 omega by 4 is equal to ft by mr. 2 plus 1 by 2 means 15 omega by 4 is equal to 5 by 2 ft by mr. 2 and 4 get cancelled, 5 and 15 get cancelled. So ft by mr is equal to 3 by 2 times of omega. This is our equation number 8. Now I'll put it in equation number 6 to find the value of omega 1 final. So omega 1 final is equal to 2 times of ft by mr. So 2 times of 3 by 2 omega. 2 and 2 get cancelled, is equal to 3 omega. And omega was 100 radian per second. So 300 radian per second. And omega 2f is equal to omega 1f by 2 is equal to 150 radian per second. So the final angular velocities of the cylinders are 300 radian per second and 150 radian per second.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.